In this video, we're going to talk about how to create the parent graphs of sine and cosine using the unit circle. So in case you have forgotten, we can find the sine and the cosine using the unit circle by looking at the x and the y coordinates. So your cosine is always associated with the x coordinate on the unit circle, and then your sine is always the y coordinate on the unit circle. So what we're going to do is we're going to start with the cosine of x, and we're going to start by just filling in a complete parent graph table using the unit circle. So what I'm going to do is I'm going to look at angle 0 on my unit circle, and I'm going to find f of 0. And f of 0 is equal to the cosine of theta. Sorry, f of theta. F of theta is equal to the cosine of theta, so I am looking for the x coordinates. So at 0, my x coordinate is 1. At pi 6th, my x coordinate is the square root of 3 over 2. At pi 4ths, I have the square root of 2 over 2. And then at pi 3rds, I have 1/2. So I'm going to have you guys go ahead and fill in the rest of this table. I'm going to hit pause and fill it in. But make sure as you go around that you're looking at the x coordinates and that you are catching all the positives and negatives. All right, hopefully when you filled those in using unit circle, you got something that looked like this. Okay. So our next step is that we want to actually plot these points on the graph on the right. So let's just take a look at our graph really fast and notice some things about it. So first of all, you'll notice that my x-axis is labeled in increments of pi, which is really nice because the inputs of our graph are these theta values, which are radian measures. Okay, so my x-axis here is in radians. Oh, let me write that in a smaller pen that you can actually read. Now my y-axis just goes from -1 to 1, and it's in decimals. So what I'm going to go ahead and do is I'm going to convert all of these fractions that I have in my table into decimals, just to make it a little bit easier for me to graph it. So 1, the first line, is just going to be 1. You don't need to change anything there. And then you're going to want to type into your calculator the square root of 3 over 2, and make sure you close the square root before you divide by 2. And let's just round to 2 decimals, so 0.87. Then we'll do the next one, which is the square root of 2 over 2, so 0.71. And then 1/2 is 0.5. Okay, and then 0 is, of course, 0. So go ahead really fast and convert all of these fractions into decimals for ease of graphing. All right, so you should end up with a table that looks like this. All your numbers will actually be the same, just kind of in a different order and with some positives and some negatives. So now that we have this table, we are going to go ahead and graph these points and plot the points. So I have a point at when theta equals 0, my function value is 1. When theta equals pi 6ths, my function value is 0.87. So I'm kind of just going to be guessing about where these points are. At pi 3rds, I have 0.5. And then between pi 3rds and pi 4ths, I'm going to have 0.71. Okay. Then at pi halves, I'm at 0. Then at 2 pi 3rds, I'm down at -0.5. At 3 pi 4ths, which is right between the 2 pi 3rds and the 5 pi 6ths, I'm at -0.71. 5 pi 6ths, I'm at -0.87. And then at pi, I'm down at -1. Okay. And as I keep filling these in, I'm actually going to start seeing kind of a pattern emerge here. At 7 pi 6ths, I'm back at -0.87. Right in between 7 pi 6 and 4 pi 3rds, I'm at -0.71. At 4 pi 3rds, I'm at -5. Let's make sure I put this in the right spot. And then at 3 pi halves, I'm at 0. At 5 pi 3rds, I'm at 1/2 or 0.5. At 7 pi 4ths, I'm at 0.71. At 11 pi sixths, I'm at 0.87. And then at 2 pi, I am back at 1. Okay, so there's all my points that I get from this graph. And you'll kind of see it kind of looks like a U. So I'm going to go ahead and connect these dots. And this is going to be a curved graph. And it's going to look like a wave. Okay. So that is what your parent graph of cosine should look like. So this is kind of the parent function. This is just one complete cycle. So see how we kind of got back to the point that we started with? If you were to keep graphing further to the left and the right, it would actually just keep repeating this shape over and over again. So with dotted lines, I'm just going to go ahead and kind of graph what this would keep looking like if you were to continue it. And it's going to look like a wave, because if you think about it, if you're getting your values from the unit circle, you're going to keep just kind of looping around and around that unit circle. So you're going to keep repeating the exact same y values as you go. So let's talk about some important key features of this graph. So first, let's just talk about the domain and the range. So the domain, remember, is what x values I can graph here. And the domain of your cosine is always negative infinity to infinity, which means that I can graph as far to the left and the right as I want to. The range is a little bit more specific. Okay, if you look at this, the smallest that my function ever gets is -1, and the biggest it ever gets is 1. Okay, and this range is going to be true for all cosine functions unless they've been shifted up or down, which we'll talk about a little bit next time. But for now, it's important to recognize that although the domain includes all real numbers, that range is pretty restricted. So you're going to start, as you keep graphing different versions of the cosine graph, you should always see some sort of pattern like this where the range is kind of bounded by two values. Okay, I'm actually going to kind of color these dashes in. If you're having a hard time figuring out what the range is, go ahead and make a dotted line that hits like the highest point of your wave and the lowest point of your wave. Wherever those dotted lines are, that is going to be the upper and lower bounds of your range. So my bottom line is -1, my upper line is 1. Okay. And there's a lot of other important features that we're going to talk about with the cosine graph that we'll get into over the next couple lessons. So let's go ahead and shift our focus now to the sine. This graph is we're going to create the parent function pretty much the same way that we created the cosine function. We have all these angles, and we're going to pull the sine values from the unit circle. So remember, if you're using the unit circle to find your sine value, you are looking at the y-coordinate. Okay, so at 0, my y-coordinate is 0. At pi sixths, my y-coordinate is 1/2. At pi fourths, my y-coordinate is square root of 2 over 2. And at pi thirds, my y-coordinate is the square root of 3 over 2. Okay. Now I'm going to do the same thing I did before. I'm going to fill in this whole column of values in the unit circle, and then I'm going to convert these numbers into decimals. Okay. So go ahead and pause in the video and fill in the rest of your table. All right, hopefully your table looks something like mine. And we're going to go ahead and graph these points the same way that we graphed our cosine. So let's go ahead and review how we did that. So this first column, this is going to be my x values that I'm plotting. And then I'm going to plot them with these y values, the decimal version of my function. Okay. So when x is 0, y is 0. When x is pi sixths, y is 0.5. When x is pi fourths, y is 0.71. When x is pi thirds, y is 0.87. And then when x is pi halves, y is 1. Okay, so I'm going to go ahead and let you guys fill in the rest of this table really fast. I'm going to jot all mine down really fast. And just make sure that you are being as precise as you can with these so that your graph is as accurate as possible. And I'm doing mine really fast. You probably need to spend a little extra time on yours. So feel free to hit pause if you need to. Okay, so you should get a bunch of points that look like this. Okay, once you have these all plotted, I'm going to go ahead and connect them. Whoops, that was a horrible job. So again, this is going to be a curved graph. I did a lot better connecting the dots with the cosine graph. So there are the points, or the graph that I get when I connect the points. Okay. So I'm going to go ahead and kind of extend my graph using dotted lines to show you what it would look like if I were to continue this. Okay, it's going to keep repeating the same cycle, going up, going down, going back to where it started. So let's talk about the domain and range here. So the nice thing about the sine and the cosine is they have the exact same domain and range. So the domain is from negative infinity to infinity, and then your range is from -1 to 1. So I can cover all the y values between -1 and 1. Okay. So we call these graphs that keep repeating themselves, like the sine and the cosine, we call these periodic graphs or cyclic graphs because they go through the same cycle over and over and over again. They just repeat themselves. As we move forward and we start looking at transforming these graphs, we're going to need to rely on the parent functions a lot. Now, graphing all of these points that we did here would take a long time to graph the parent functions and then to transform all the points. So we are just going to be looking at, when we start graphing parent functions later on, we're just going to use these shaded boxes. So to create a parent function, you're basically just going to plot increments of pi halves, which gives you the places where your graph crosses the x-axis, so basically like the middle of the graph, and it gives you the points at the very top and the very bottom. Okay, so all these intermediate points that we found, the pi 6, the pi 4, those are important if you want a super accurate graph. But as we start graphing just on repetition a lot, you're just going to use these five points to get an accurate parent graph.